This case study of a fiberglass manufacturer that used big data management and analysis tools to understand and improve their manufacturing process is brought to you by JMC Data Experts. Owens Corning produces insulation in dozens of grades at 3 locations on multiple manufacturing lines. They needed a better understanding of their process to learn how to consistently produce the highest thermal resistance, or K rating, in their insulation. A download of 2 years' production numbers contained thousands of rows of data, but unfortunately also errors, noise, insignificant correlations, and irrelevant information. Big data analytics is a library of data manipulation and statistical tools used to prepare data for analysis and then sort through very large industrial files with high levels of noise and variability. Experienced analysts know that it takes just as much time to prepare a data file as it does to analyze it. For this data set, many manipulation tools were used. For example, coding was used to clean up thousands of syntax errors in just one command. Pareto analysis and subsetting simplified the trivial many to the vital few. Extraction converted date-time information to key stratification variables. And calculator functions were used to create important response and input variable columns from text and continuous information in the dataset. After a thorough cleaning and preparation, the data was finally ready to analyze. Comparisons of process performance between different raw materials, machines, locations, shifts, etc. are always important in the analysis of historical data. In our case, the performance of 5 manufacturing lines for 2 product grades were compared with a box plot. The box plot identified Indiana Line 2 as having the most consistent thermal resistance, but Pennsylvania Line 2 had the highest average output. What was it about their processes that led to this performance? Finally, outlier values, both high and low, were identified, and the extrusion, vacuum and graphite process settings associated with these outliers were found using variable identification. Correlation analysis allows you to determine relationships between response variables and process variables. In this case, thermal resistance has a strong positive relationship with density, but very little association with thickness and extrusion rate. Also, vacuum and thickness, 2 input variables, are correlated. This is important because identifying correlations between input variables is critical before a successful regression analysis. Because it is so easy to use and interpret, as well as its tremendous value, correlation analysis is a staple in evaluating historical data. Relational graphics and modeling are key to visualizing and quantifying the relationships in your data. A line plot of K rating versus fiber density takes our correlation results one step further by showing the size and strength of the relationship. By grouping the data, we see that a compaction step in the process also affects the relationship. To accurately predict K rating as a function of fiber density, compaction must be included in the model. This leads to 2 equations to describe the relationship. Finally, all data occurs over time, and a complete understanding of any historical data requires reviewing time series plots. Here, we see that thermal resistance follows a cyclic pattern, varying between about 2 to 4 BTU per hour foot squared every few weeks. There are also outliers as low as 1. Using variable identification, we found the outliers are associated with high spin weight, the compactor off, and the use of TS pretreatment. This provides clues to the cause of these defects. Plotting more than one variable over time often uncovers relationships. Here, the cycle in our response was negatively correlated with the same cycle in machine speed. In understanding production data, time series analysis is critical to identify trends, shifts and relationships, as well as the cause of outliers. In the end, our fiberglass manufacturer learned which process produced the highest and most consistent response, key drivers of thermal resistance, an estimate of their overall process variability, and the causes of many defects. Implementation of their improved process understanding led to fewer defects in manufacturing and in the field, as well as higher process yield across all facilities. If you would like to use big data management and analysis methods to improve your process performance, or if you have any questions about this case study, contact us at JMC Data Experts.